The next unit looks at you developing an algorithm and some of the steps that you might think about on developing an algorithm. The problem says you're going to read in pairs of positive numbers and print each pair in order. So if the first pair of numbers that come in are 8 and 4, you should output 4, 8. Okay, so you're going to print them in numeric order. If there is more than one pair, we have to loop. So here is the first stab of the algorithm. While not done, what are we going to do? I'm going to prompt the user with a write statement to enter two values separated blank. So if the first number they enter is an 8, then number 1 would contain an 8. If the second number they entered was a 4, number 2 would contain a 4. And then we got this print them in order. And so we would print a 4 and an 8. And we would loop back up. Okay, so that's a good initial start, but there are some problems. How does the computer know when not done is done? Okay, when does not done become a false statement? In other words, when are we done? Some kind of input from the user might need to happen to know when we want to be done. Okay. Another problem is, well, that's not enough detail. Yeah, it's kind of vague. What does print them in order mean? The computer does not know what you mean by print them in order. So a little bit more detail, please. Okay, so here's the solution to problem 1, ending the loop. So you, the coder, you're going to decide how to do this. You could ask them how many pair of numbers to order and to put in order, and if you do this, then you have a counter-controlled loop. So let's take a look at the solution here. Notice that our while loop has changed from not done to relational expression. So I'm going to compare two numbers. Is pairs read less than number of pairs? Okay, well, how many pairs? Okay, so how do we get the value into the number of pairs? So the way I read this, what the author's trying to say is, you're going to tell me how many pairs of numbers that we're going to sort, and I'll loop that many times. So he will output here how many pairs of values are to be entered. And the user is going to enter a value. Let's say 3 pairs of numbers will be stored in that variable. So now here, that's right, number of pairs, so that's going to have a 3. This initializes. Well, how many have you sorted so far? That's kind of what that's saying. Before you start looping, let me set how many we've read in so far, and we've read none in. So this will be 0. Is 0 less than 3? And that's a true statement. We go into the loop, and we'll write, okay, hey, enter your two numbers. Let's go back, and we'll say 8, 4, and we'll print them in order. Now this algorithm is missing something. As written, this algorithm is an infinite loop. Because how many pairs did I just read? I just read 1 pair, but yet pairs read has not been changed. So what really needs to happen here is a statement that will increment pairs read. Pairs read is equal to pairs read, whatever's in pairs read so far. Well, right now it's a 0 plus 1. Okay, so as I just have written it, I've removed this infinite loop, and pairs read will now be 1. So this comes up, this changes it to 1 here. This will be a 1. Is 1 less than 3? Sure. Well then, the output, enter two numbers. Okay, now I'm going to enter two different numbers, say 20 and 30. And this, we got to rough that out a little bit, but for right now, assume it works. And so it prints them out in order, 20, 30. I come here, and what happens? Well, pairs read is 1 right now, but we're going to add 1 to that 1, so 1 plus 1 is 2. So now it'll be 2 when I come up here to compare. So now this will be 2. Is 2 less than 3? Sure. Okay, enter 2 more pairs, and I will enter 2 more pairs. Let's say 10 and 2. Well, we'll print those 2 pairs in order. order. Okay, 2, 10. And then we'll, okay, so we got to take whatever's in pairs red, which is 2 so far, and add 1. 2 and 1 is 3. And so 3. Pairs red will now have 3. We loop back up. And the question is, okay, so pairs red is 3. So the question is that a true statement? Is 3 less than 3? Well, that's false. 3 is equal to 3. So that's the end of the while loop. Okay, so that is the first problem. And as okay, so this is the author's stab then to remove all the problems. So like once again, we're going to prompt. Okay, we're going to use a counter-controlled loop. How many pairs? And the variable name's changed. It looks like now instead of pairs red, it's number red. And so that's initialized to 0. And so all of this works just the same. The author wrote the statement to increment by 1 a little bit differently, but I can read that. Take number red and set it to number red plus 1. What we really changed right here is how to put it in order. Let's take a look at this just for one set of data. Remember one time I had 8 in number 2 and 8 in number 1 and 4 in number 2. Let's say that's the case. If 8's in number 1 and 4 is number 2, is that a true statement? Is 8 less than 4? That's a false statement. Well, since that's a false statement, it comes down here and does the statement in the else part, which says print number 2 first. Okay, so output will be this. Then print a space and then print number 1. Okay. Let's say instead number 1 is 20 and number 2 is 30. So what happens with this if statement? Okay, now number 1 is 20 and number 2 is 30. So we're testing. Is number 1 less than number 2? And that's true. Number 1, 20 is less than 30. So then that means we'll do the true part of this if. And we'll output number 1 first. And then we'll output a space. And then we'll output number. And yeah, that algorithm seems to work. Now if you recall, the step-by-step process of solving this problem is actually an application of abstraction. Remember, abstraction we talked about in the first week is when you remove the details to help you focus on what you're working on now. And so we removed the details of how to do that ordering, so we focused it on last actually. What were the abstractions in algorithm 1? Not done. The details on how to exit the loop and print them in order. Using abstraction is a problem-solving strategy known as divide and conquer. Okay, the author then shows you a walkthrough of the algorithm. Go ahead and do that. And it shows you before the loop the values of everything. And then the first time through the loop, we're looping 3 times in this example. So first time through the loop, second time through the loop, third time through the loops. Shows you how the data that is in the variables changes each time through the loop. The process of stepping through like I was doing on the earlier and figuring out the contents of every variable at any moment is called a walkthrough. The very end of chapter 6 discusses testing. After you develop an algorithm, test by doing that walkthrough that we just did, and if you get the expected results. If you don't, then check your logic out, see what's wrong. Sometimes you don't see the error in the algorithm, in the pseudocode. You enter your program and you got to test again because the computer will run it exactly as you wrote it. So even though I didn't see it in the algorithm, the computer might catch any logic error you might have. Clear box, which is also known as white box testing, and black box testing. If I know, for example, the source code, I know, do you remember this structure where you can go true on one side and false on the other? I know that there's an if statement, and I want to make sure I write test data that goes on both sides of the if statement. That's called code coverage. You want to make sure that the testing values go through both sides go through every possible branch. Even if you have hundreds of ifs, You want to make sure every possible branch is tested. That gets very difficult to do when you're testing a huge program that can be ran on multiple operating systems and versions, etc. So there's actually jobs for people that's what their job is. They just test. Black box testing means I don't know the source code. I don't know if there's an if statement there or not. So how am I going to know how to set the test data up to make sure that every path in my source code is covered? Well, I just make sure I cover all of the datas. Okay, so I make sure that zero is always included, positive numbers, negative numbers, so that any possible data, if I ask you to input how many pairs, and I might even test for a string. Did you enter mom? Well, that's not legitimate. What happens? Okay. Finally, I just want to say that a lot of new development is actually written. This seems kind of funny. You write the test first. It seems like we should write the program and then test. But a lot of programmers are doing something called unit testing, in which they write the test first, then they write the actual source code. Okay, I'm going to ask you to do a couple of these, step through a couple of these, and that wraps up our talk on expressing algorithms.